Hi, and welcome to Mighty Math, the channel that makes all kinds of nice mathematical concepts accessible, understandable, and lovable. On today's video, I'd like to work out a problem with a very nice solution demonstrating the principle of superposition. Suppose we have an object with a force applied on it to the right. Given that there's nothing to stop it from moving, it would start moving to the right. If we also had a force to the left identical in size, then we would expect it to stay put because the net force on it is zero, with both forces annihilating one another. This would also be the case if we had 3 forces, 4 forces, 5, 6, as long as they are equal in magnitude and equally spread. If we think of the object as a small square or even a point, then the forces represented as arrows of equal length would form a regular polygon, a polygon with equal sides and equal angles. We could have as many forces as we like going in different directions operating on this object as long as they are identical in size and placed so that they cancel out one another. If it is an even number of forces, it's obvious because every force has a force directly opposite it. But it is also true for an odd number of forces. It can be shown with some basic trigonometry, and it makes a lot of sense too. But what if one of the forces was missing? If there's nothing stopping the object from moving, where would it go? In case there was an even number of forces, we could try and understand which forces still annihilate one another and find out what is left. In this case, a single force pointing to the right is left, and that's where the object will move. If there is an odd number of forces, it could get a little more complicated, but there is a very elegant way to work it out. We know that if we have 2 forces identical in size pointing in opposite direction, it is as if there is no force on the object. The net force they apply is 0. So, where we have the missing force, we could place 2 forces identical in size and opposite in direction, and also identical in size to all the other forces. Now, compared to the situation we already know, we actually have one additional force, not one missing. But that makes it a lot easier because all the forces drawn in red are equal in magnitude and equally spread, so they cancel each other out. Those are the 15 original forces that canceled out one another. We're left again with the single force applied on the object, and it obviously points to where the object would move to. What we did here is apply the principle of superposition. Very generally speaking, this principle can be applied when linear functions are involved, enabling us to break down complicated systems into small, simple elements forming them. Waves, electrical circuits, forces, fields, vectors of all kinds, all have that superposition property. Thus, treating them becomes much easier because we can simply add or subtract these elements like we did here. Trying to work out this problem using trigonometry would bring us to the same solution, but it's so tedious compared to what we did. I hope you enjoyed this video and I hope you love math, because when you love math, math loves you back. And if you hate it, it hates you back with a vengeance. Please make me a happy man by subscribing, a like, maybe a comment. Until next time, bye-bye. It's making me dizzy, enough already.